voltage probe here. So I'll take the probe option here. So here we have a probe option. Click on the probe and then select voltage probe. So I'm going to add here in this one and output side. So output of the capacitor is C1 and then says capacitor C2. We will check how much. See, the variation is from 39 to 40. So variation is very low here. So it is from 39 to 40 and this one is 5 volt, no variation. So this 39 means in the waveform, so the starting waveform starts from 39 and it will go to 40 and again gradually decreases to 39 and again it will go to 40 and gradually decreases to 39. So if you want to make it clean DC, so we have connected another capacitor here and then we do not have any variations, we get the clean DC here. So what happens if I reduce the capacitance here? We'll see. I'll just remove this and I will reduce the capacitance to 1 microfarad and see what happens in 1 microfarad. We will run the simulation. So you can see now in 1 microfarad capacitance the variation is too high. So variation is too high, that means so it is varying from 19 voltage to 40. So if this is 19 and it is go to 40 and again it will come back to 19 and again it will go to 40 and again it will come back to 19. So we will see the waveforms by connecting the oscilloscope. We will connect input. This also will connect to input and now we'll see the C output here. So we'll run the waveforms. You can see the C waveforms here. So it is varying too much. So it is varying from this point. So this is 19 voltage. So this is 0 voltage. This is 19 voltage. And this is peak 40 voltage. So it is reducing from 19 to 40 it is going and again gradually it increases to 19 back and again it goes to 40 and it is go to 19 back again. So this variation is too high here, so filtering is less. So if I increase the capacitance, so obviously the filter will increase. So I'm going to go for 25 microfarad just for an example. See how it looks like. So you can see here it is varying from 38. So you can see the waveform here. Waveform is quite different if we compare to the previous one, 1 microfarad, and now it is from 38 to 40 variations. So likewise at the output side of the circuit 05 we are getting 5 volts clean DC. We will connect we will connect one resistor and LED and we will cross check whether we are getting the continuous supply or not. So we'll add LED here, LED indicators. I'll go for active LEDs. So to protect the LED we will add one resistor. Take 100 ohm resistors are more than enough. So we'll connect resistor and then LED. This part we have to concentrate here. Click on here, so you can see the LED is glowing. This is yellow color LED. It's glowing on full. So what if I increase this resistance here? So I'll go for a 500 ohm resistor and then click here. So resistance is more. See the glow compared to 100 ohm resistor and 500 ohm resistor. The glow is too less now. It is not brightness is low now, because increasing it resistance. So whenever we increase the resistance, obviously the current decreases. When the current decreases, we are seeing the low brightness is low here at the diode side, LED side. So if I decrease the resistance to like 50 ohm, so click OK and then you run. So you can see the full glow here. That means whenever I reduces the current here, voltage resistance, and the current goes high. So whenever the current is high, you can see the diode LED is glowing in a full brightness. So this is the way how we do simulation step by step. So we have taken the generator here we generated the sine waveform with the amplitude of 40 volts, and then we used the diodes here. In practically we don't use these two diodes, but in other words we will use a combination of 4 diodes and we will make a bridge rectifier. And here, just for simulation purpose, I am going to only use 2 diodes to understand it clearly. Here the capacitors are used to filter this waveform, unwanted waveform from the positive half cycles. Based on the capacitance, it will change its value. And then 7805 voltage regulator, it regulates between 40 volts to 5 volts, and it will give the clear 5 volt DC. And then clear 5 volt DC, we have connected one capacitor to block any variations in the output waveform of the 7805 regulator. And the resistance here we have added to control the current flow across the LED. So LED is glowing on continuously, that means we are receiving the clean DC. If you have any variations here, so LED will not glow continuously. If you have any variations, it will go, it's like a blinking, it's like a dim. So now we have got clean DC, so the LED is glowing continuously. So thank you so much